Hello, in this lesson, we will review lesson 4.1, which talk about angle relationships of angles formed by parallel lines cut by a transversal. So let's just do a little review of what we've done in class today. So we said given the two lines are parallel, so L1, L2 is parallel. And let me kind of highlight, you see that this is L1, this is L2, and my transversal T, let me write it a little better. This is T transversal. So given two lines are parallel, there are a bunch of angles that are congruent, and there's also angles that are supplementary. Let's kind of learn a name here first. So we say, well, when I think about corresponding angle, just name of the angle. Kind of don't want that color here. Okay. Name of the angle first. Corresponding angles means angle in about the same location in formed by the parallel line. So for example, angle 2 and angle 6 are corresponding angles. They are both about the parallel line and they are both on the same side of the transversal. And alternating, the keyword is alternate here. Alternate tells me I am on either side of the transversal. So alternating means I'm on the left hand side or on the right hand side. Interior referring to angles inside the set of parallel lines here. Think of it as inside the river. So this parallel line here, L1, L2, or like your river. So you're inside the river. So alternating interior angles are congruent. So I'm referring to angle 4 and 6. Okay. Exterior. When I say exterior, I'm referring to side that's outside the parallel line. Say things out here and then here. So here, exterior. Okay. So that's what we're referring to. So let's name each pair of angles. So corresponding angle we said is angle 2 is corresponding to angle 6. So angle 2 is congruent to angle 6. Corresponding angles are congruent. I can also say angle 4 is below the L1, angle A below L2. So angle 4 and angle A are also congruent. So angle 4 is congruent to angle A because they're corresponding angles. Now let's look at the left-hand side, the same thing. I could say angle 1 is corresponding to angle 5. They're both about the parallel line on the same side of the transversal. So I say 1 and 5. So angle 1 is congruent to angle 5. I can say the same thing about 3 and 7. So angle 3 is congruent to angle 7. Now let's look at alternating interior angles are congruent. Well, alternating on both sides of the transversal, alternating. Interior refer inside the two parallel lines here. So that's 4 and 6. Let me write it. So I'm saying angle 4 is congruent to angle 6. Same side interior angles are congruent. 4 congruent to angle 6. I can say the same thing about angle 3 and angle 5. So I say, well, angle 3 also congruent to angle 5. So say angle 3 congruent to angle 5. Okay. Now let's look at alternating exterior angles are congruent. Well, that tells me that alternating both sides, exterior or outside. So that's referring to angle 1 and angle 8. Alternating exterior angles are congruent. So angle 1 congruent to angle A, alternating exterior. The name, again, learn the name. So next is, besides 1 and 8, 7 and 2 are also alternating exterior. So angle 2 is congruent to angle 7. Okay. So these are the angles that are congruent. Now let's look at angles that are supplementary. So again, I am interested in angles that form by the parallel line cut by the transversal. So parallel line cut by the transversal, I look at the angle. So in this case here, I have 4 and 6. When I add it together, I get 180. That's what supplementary means. Supplementary angles are angles that have sum of 180. So I say measurement angle 4 plus measurement angle 6 should give me 180. I can say the same thing about 3 and 5. So measurement angle 3 plus measurement angle 5 also give me 180. So same side interior angles are supplementary. I could say the same thing about same side exterior angle. So same side exterior angles are also supplementary. Let's say this is 2 here. Same side exterior. Again, I'm outside the parallel line here. So 2 plus A gonna give me 180. So measurement angle 2 plus measurement angle A, I get 180. I say measurement angle 1 plus measurement angle 7. Oh, let me run first. plus measurement angle 7 also give me 180. Okay, so their same side interior angles are supplementary. So all these angles are, so look at this picture here. All these angles are either any pair. Give me any pair. You can pick, say, 3 and 6, right? They're congruent. So, or you could say 4 and 2, they are added up to 180. So given this picture here, any pair of two angles, they either congruent to each other or they have the same, or they add up to 180, or supplementary in other words. So any pair of two angles formed in this picture here, which is formed by a parallel line cut by transversal, are either congruent or supplementary. Now, before that, let's also review something that's important. Angles that's not formed by parallel lines. So in class, we mentioned that vertical angles are congruent. So again, let's think about vertical angles. Let me put 6 here. So if, let me draw a picture first. So let's say vertical angles. Now notice that this vertical angle only need line to intersect. So I could make, say, this is 1, 2, 3, 4. I could say 1 and 3 are congruent here because vertical angles are congruent. Vertical angles congruent. Now note that I do not need parallel line here. I only need two lines to be intersecting. If they intersect, vertical angles are congruent. Let's say angle 1 measurement is congruent to angle 3, angle 4 is congruent to angle 2. So those are also common use one. Another set of angles we use are like supplementary angles. Well, supplementary angles, the angles that form linear pair, you could call them linear pair, or angles that form the same line. Let's call this, say, 5 and 6. So when you see a straight line right here like this, so adjacent angles, opposite rays of adjacent angle supplementary here from a straight line. I could say measurement angle 5 plus measurement angle 6 equal to 180. No, I know that a straight angle and they're adjacent to each other. Okay, so those are common things that we use in a proof and solving. Now let's use the parallel line here. So use this theorem, this summary. If two lines are parallel, then corresponding angles are congruent, alternating interior angles are congruent, alternating exterior angles are congruent, same side interior angles are supplementary, same side exterior angles are also supplementary. So I'm going to use that information if you're going to solve a question, solving for x. So let's look at example 4 from your lecture 4.1. I'm going to redo this example here. So we have given that two lines are parallel, A is parallel to B. So when it given something information here, I'm going to color code it. Given is green, I can use them. A is parallel to B, I'm going to mark it. Well, with a transversal K, this is my transversal. I'm telling you, I know the angle 2 is x plus 4 times x minus 3. Angle 7 is equal to x squared minus 3. So let's look at location in terms of relationship with these two angles here. Angle 2 is alternating because they are on different sides of the transversal, right? And the in exterior because they're outside the parallel line. So angle 2 and angle 7 are alternating exterior angles. Therefore, they are congruent. So I could say angle 2 is congruent to angle 7. Well, if two angles are congruent, then they have equal measures because, let me write a reason here. Alternating exterior angles congruent, and having congruent tells me they have equal measures. Measurement of angle 2 is equal to measurement of angle 7. Now I just substitute it in and solve. So measurement angle 2 is, I have x plus 4, okay, times x minus 3. Measurement angle 7 is just x squared minus 3. Now I just solve for it. On over here in the algebra class, we say you can do FOIL, or you could do the box method in your algebra class. This is what I mean here. So to write multiply, I could just say write one of them horizontally, one of them vertically. So x positive 4, x negative 3. Hopefully you learned that in your algebra class. So I say x times x, give me x squared. X times 4, give me 4x. Negative 3 times x, give me negative 3x. Negative 3 times 4, give me negative 12. Now, I can just combine like terms. Notice that this 2 3x and 4x, negative 3x and 4x is going to give me positive x. So the solution is I have on the left hand side, I have x squared plus x minus 12 is equal to the right hand side here, which is x squared minus 3. Now it's just a matter of solving. So now to solve this, let me just a little lower. I could just subtract x squared to both sides. So subtract x squared to both sides. I rewrite the equation. Now I have x minus 12 is equal to negative 3. Now I can add 12 to both sides. Okay. Adding is called addition probability equality when do proof. So you mind it. So x is equal to 12 minus 3 or negative 3 plus 12. And that is 9. So x is equal to 9. Now let's say I want to solve for angle 7 or angle 2, for example. I could just substitute x equal to 9 into the expression. So let's do it. Again, the question doesn't ask you to solve for it, but here I'm going to solve. So measurement angle, let's say 7 we want to solve, is equal to measurement angle 7, x squared minus 3. X squared minus 3. I'm going to substitute x. X is 9. So I have 9 squared minus 3. So I have 81 minus 3. And that is 78. So when you substitute it into angle 2, you should get the same answer because measurement angle 2 and 7 should be the same. So just check see if we do it correctly. So measurement angle 2 is equal to x plus 4 times x minus 3. And I'm going to plug it in. X is 9. So 9 plus 4 times 9 minus 3. So I have 13 times 9 minus 3 going to give me 6. So multiplied it is 3 times 6 give me 18. 1 times 6 is 6 plus 1, 78. So 78 degrees. So we do it correctly. I can check that they have the same measure. So this completes the lesson review for 4.1. Thank you for watching the video.